Good morning, Cayman's Mr. Iker here, coming at you to bring a lesson about probability. This is our new unit. I'm going to do a couple lessons on probability and statistics, two things very close to my heart. So in this first lesson, we'll talk about basic idea of probability and what are called two-way tables. So I have a two-way table right here. Here's some data that a certain teacher pulled from a certain school pathways website. So as the question says, an administrator at a certain high school was interested to compare how many students lived in nearby towns who attend the school and to compare this with the gender of the student. So for two-way tables, we have the different towns that students live in, Escondido, Oceanside, San Marcos, etc. Now, there are quite a few towns that these students can come from, so there's a big other category. And then we have if they've been identified as male or female. We can also see the total number of students at this school, 1,242. Notice the total columns here. Now, no surprise that this is our high school, and you might think that we don't have that many students, but including the studio plus the online plus the independent study program, we have that many students whenever whenever the administrator pulled this data. So the first question, just to make sure you know how to read and understand what this table is telling you, what does the 76 represent in this two-way table, and what does the 65 represent? So let's interpret those. The reason why it's called a two-way table is because there's two variables. There's this variable up here, the gender of the student. Then there's this variable over here, the town that they're from. So that's two. And it's called the two-way table. So what does the 76 represent? Well, the 76 represents that there are 76 students who are female who live in San Marcos. And what does the 65 represent? Well, that represents there are 65 males who live in other areas not listed. So like Murrieta or Fallbrook or other places. So we would say 76 represents that there are 76 females who live in San Marcos, or as I like to call it, San Marcos. And then the 65, there are 65 males who live in other areas. Now, if you're a female who lives in San Marcos, can I get a whoop whoop? And if you're a male who lives in other areas not listed, can I get a whoop whoop? All right, that was exciting. Letter B, what percentage of students are female? Percentage of students. So we're going to need how many females, total females, that there are at the school. And we're going to have to divide that by the total number of students at the school. So I see that we have 670 females, and there are 1242 total students at the school. We're going to divide those to find a percentage. So 670 divided by 1242. We'll round to 3 decimal places, 539. That's the decimal. To convert that to a percentage, we'd say there's 53.9% who are females at the school. This might be an interesting statistic for school administrators to know, the breakdown between males and females, or the breakdown between different grades, different locations. I know for our school, often people are interested in the breakdown of how many students come from different areas. How many Vista students are we serving? How many Valley Center students are we serving? So this is one way that this data could be interesting to someone. Question C says, what's the probability of randomly selecting a female student from this school? I want to highlight a very important idea that B and C are really going to be the exact same answer. The percentage of students who are female was 53.9%. The probability, the chances that if you just pick a random student from a list of all the students at the school, what are the chances that you would randomly pick a female? That's going to be the exact same number. So we're going to have that 670. How many females are there? And how many total options are there? And we're going to get this probability. Now, typically probabilities are left as numbers between 0 and 1. Number between 0 and 1. So this represents the likelihood that we would pick a female student from a list of all the students. So again, really, really important. It will help you understand how to calculate these things with two-way tables if you understand that the percentage that are female is the exact same question, exact same answer as what's the probability of randomly selecting a female student. Now, just as a side note, we say randomly selected, randomly selecting. That's just because, if I just said what's the probability of picking a female, then you might say like, oh, 100%, there, right there, there's a female, pick her, 100%. That's not just selecting anyone that you come across, but actually picking them randomly. And how to do that is something you talk about in later classes, how to do that effectively to make sure it is truly random, rather than you just picking someone that you think it might be random, but it isn't really random. But anyway, letter D, what percentage of students live in Escondido? If you'd like to pause the video, you could do that. But what percentage live in Escondido? Well, we need to know the total number of Escondido, total ESCO, we'll say, not Visco, but ESCO, total ESCO, divided by the total number of students. So total Escondido looks like would be this number. All the males, all the females, add them together. And then our total, again, is the 1242. So we'd have 541 divided by 1242. So what percentage of our students actually do come from Escondido? That would be a really important question for the administrator to have an answer to. We would get this rounded to the third decimal place. It was 5.5, but we'll round it up to a 6. So as a percentage, that would be 43.6%. And then I hope you notice that if you read E, D and E are really the exact same thing. Again, I want you to understand how to calculate probability from a two-way table. And to calculate that from a two-way table, it's the exact same thing as finding a percentage from a two-way table. So what's the probability of randomly selecting an Escondido resident from this school? Well, again, you would have, there are 541 Escondido residents out of 1242. And the probability, which is a number between 0 and 1, the probability would be 0.436. So really the only difference is one we convert to a percentage and the other we leave as a decimal between 0 and 1. Okay, let's get try one, letter F. Letter F, we're jumping right to what's the probability. So instead of asking the percentage like I've asked in the previous two, let's just jump to what is the probability of randomly selecting a male student who lives in Carlsbad. So we need a male student who lives in Carlsbad. So males, find the male column, and then Carlsbad. It looks like this number right here. There are only 28 students who are male who live in Carlsbad. So that would be 28 divided by 1242. So as a probability, we would write it as 0.0 2, and then 2, 5, we'll round that up to a 3. And we'll leave it written as a number from 0 to 1, so that would be our probability. Another note about notation. Now, this is the same exact decimal. I just haven't included the 0 up in front, but I would recommend including the 0. It's a little easier to process. I know for me, it's easier to process if I see the 0 point something rather than just leaving it as a dangling 0.023. So that's our probability. So I'm trying to make sure you can jump from, hey, if you can find a percentage, then you can find a probability. And this one, we were looking inside the table for males who live in Carlsbad. All right, let's progress. Let's see, there we go. What's the probability of randomly selecting a student from Escondido, Oceanside, or San Marcos? Now, I think at this point I should probably erase some things from the table. Okay, so probability a student is from Escondido, so there's that many students from Escondido. Oceanside, there's that many students from Oceanside. Or San Marcos, there's that many students from San Marcos. So we would say we're going to take, we need the total Esco plus Oceanside plus San Marcos. And we're going to divide that by the total of all the students. So Escondido plus Oceanside students plus San Marcos students all over the total number of students. So this will give us 541 plus 114 plus 136. So 791. It's quite a big chunk of the student body. Divided by 1242. And we get 0.637. And it asks for a probability, so that'll be our probability. So not so much a 50-50 chance, a little better than a 50-50 chance that you'll get a student from one of those areas. Next question, we see what is the probability of randomly selecting a female from Vista or from Oceanside. So female is the first column, female from Vista. There are 43 females from Vista, or from Oceanside. There are 56 females from Oceanside. So we're going to have the total Vista plus Oceanside, and we're going to divide by the total number of students. That'll be the percentage, basically, which corresponds to the probability. So we have 56 plus 43 divided by the total number in the table. So that would be 99 out of 1242. And 99 divided by 1242 is 0.797. 0.0797, the 7 rounds in. So that would be 80. And that would be our probability. So there's and as in terms of percentage, there's an 8% chance that you would get a student, a female student from Vista or Oceanside if you randomly selected a student. All right, the next two questions, I'm going to change it up a little bit. So let me get the table all set. The next two questions say, given that the person you select randomly is a female, what's the probability she'll be from Escondido? So this term right here is a big, big important word, given, and we're going to see it on the next two. So given that you select a female, if it says given you select a female, basically you're ignoring all the males. Maybe a good thing to do. No dating, remember girls, no dating, ignore the males. And we don't need any of these total numbers. We're only looking at the females, given you select a female. Given you select a female. And then the question says, what's the probability she'll be from Escondido? So let's look at this and say, well, here are my females. I have 670 total females. What's the probability she'll be from Escondido? Well, how many are from Escondido and females? There's 300 of them out of 670. So to calculate this probability, we need the total females from Escondido, let's go, divided by not just the bland total like we did on every problem before this, but we need the total females. So the total females from Escondido is 300. The total females is 670. So we have 300 divided by 670. And the probability would be 300 divided by 670, and that would be 4477. So that would be 0.448. And that's our probability. This is called a conditional probability. A conditional probability is one where a conditional probability is one where you're not dividing by the total number, 1242, but you're dividing by a subset of that 1242, a smaller part of that 1242. And here we divided by 670. And I want to show you that even though letter J sounds similar to that, it's going to be a different probability, or probably will end up being a different probability. So this says, given the person's from Escondido, what's the probability she's female? So here it's very close reading. The given is the condition, given that the person you select is from Escondido. So let's go back to this table, and I need to do some erasing again. And this says, given the person is from Escondido. So you want to make a conjecture of what the answer is going to be. You want to pause, need some time to think about that. So given the person is from Escondido, given they're from Escondido, that's our condition. We could ignore all these other towns. Sorry, all the other towns. But we're going to ignore all the other towns. We're only going to look at the Escondido data. So the question was, given that they're from Escondido, what's the probability they're female? Well, you need to know what's the total number of females in Escondido and how many total students are from Escondido. So let me write that down. So we would have the total ESCO females divided by the total ESCO residents. So the total Escondido females is 300. Total residents from Escondido is 541. 300 divided by 541, and we get 5545, 0.5545. The 4 is going to round up to a 5. So we get this probability, 0.555. Notice these answers are different. Even though they sound really similar, we have female Escondido, Escondido female, but notice in the end, our denominators have switched. Our numerator is the exact same 300, but our denominators are different because we have a different condition, whether the condition's female like an I or the condition's Escondido like in J. So those are conditional probabilities. And then the last question I'd like to ask the administrator might be interested in, or maybe accreditation teams who make sure that we're a good school, maybe they might ask this question: which town has the biggest disparity in the percentage between females and males? Now, once we answer that, we won't really be able to tell like why that is, but we can make conjectures, and that's interesting to do. Sociologists, people like that do those kind of things. So which town has the biggest disparity in the percentage between females and males? So let's look at the entire table again. That's kind of cool. And okay, here's the table. Zoom in on it. So biggest disparity, it kind of means like there's way more females than males, or vice versa. There's way more males than females from a particular town. So we're going to kind of be looking across each town. So let's just look at Escondido first. It looks like there's quite a few more females than males. If there isn't a disparity, you'd kind of expect maybe something like Valley Center. Notice there's about an equal number of males and females who come from Valley Center. Some of them are pretty close. Valley Center is very close. 43 and 47, that seems kind of close. 76 and 60, that seems kind of close. Like, which one's closer? Well, the way that you calculate that and figure that out is finding a conditional probability. So for San Marcos, for instance, if you did 76 divided by 136, that means 56% are females from San Marcos. And then 100% minus that would be 44%. So add those up, that's 100% of San Marcos individuals accounted for. If we did the same thing for Vista, that would be 48% compared to 52%, et cetera, et cetera. We could do this for all of them, but I think you could probably notice which one looks like the biggest disparity. It looks like Escondido. Oops. Looks like Escondido is going to have the biggest disparity. So if we actually calculate those 300 divided by 541, that would be 55%. And 241 divided by 541 is 45%. So actually, what we initially thought, just looking at the numbers, San Marcos actually has a bigger disparity. There's a bigger gap in the percentages, 56 to 54. Now, that's pretty close, but that's kind of surprising. Just looking at the numbers themselves, we might think, oh, there's way more females than males from Escondido, but it's actually San Marcos is a little bit more of a winner when it comes to that. And if we do the same thing with San Diego, there's 56% and 44%. So San Diego has about the same disparity of males and females from their location. Oceanside, those look really, really close. I don't think that's a 51%. Valley Center, 25 divided by 51 is 49%. Carlsbad, that would be 53%. Other locations would be 53%. So actually what we initially thought was wrong. We initially thought maybe Escondido would have the largest disparity just because the numbers looked so far apart. But actually, it's kind of a tie between San Marcos and San Diego. Now, with both of them having more females than we'd expect, if it was like a 50-50 chance, you know. So it's kind of interesting to wonder, why is that? Maybe we'd want to check the demographics of San Marcos and San Diego. Maybe there's just more female teenagers in those areas, and that's why we have a larger percentage from San Marcos or San Diego. Or maybe there's something else that is explaining that. So to answer this question below, we would say San Marcos and San Diego. Which town has the largest disparity? It's a tie. Both San Marcos and San Diego have a higher percentage of females, which was 56%. Than males, which was 44%. Those towns have the biggest difference. percentages, with Escondido a close second at 55%. All right, the last type of question I like to address in this video is suppose we select two students rather than one student. All the previous questions, we were only ever talking about one student. Now let's talk about two students, randomly selected without replacement. Without replacement means you can only be picked once, or in other words, once picked, we won't put them back or replace them. So when we say without replacement, we're not putting them back, not replacing them. So what's the probability they both will be from Escondido? And this is a without replacement probability. So let's check out Escondido. And we have, what's the probability they'll both be from Escondido? Well, we need to know how many are from Escondido. There's that many from Escondido. And there's this many total. So first, we'll figure out what's the probability that one of them is from Escondido. So we need probability the first is from Esco. This P that I've used there with parentheses, that's notation for probability of the certain event that you're looking for. So probability the first is from Escondido is 541 out of 1242. And then when you select a second student, you're going to be multiplying by a second fraction. That second fraction, that's the first from Escondido. The second fraction is now, so since you're not replacing them, now your numbers here are going to change slightly, right? You're not going to have as many students now. You don't have 1242 because you just took one out. Now you have 1241. And you don't have 541 students from Escondido. You have 540. So this probability is the second is from Escondido. And then to calculate that, when you're taking two, you'll be multiplying them. So that would be 541 over 1294 times 540 over 1241. So the probability that they both would be from Escondido when you multiply that out is 0.1895, which rounded would be 190. So there's a 19% chance that you would get two students from Escondido. Let's look at one more example like that. What's the probability the first will be from Vista, and then the second will be from Oceanside? So the probability the first is from Vista. There are 90 students in Vista, or from Vista. 90 students. So Vista divided by the total out of 1242. And then we're going to multiply that by another fraction. Again, this is without replacement. So how many students are from Oceanside? There are 114 students from Oceanside. 114. Now that number is not going to decrease by one like it did in the previous one because this is a different location. If you've selected one student from Vista, you still have 114 from Oceanside. But our denominator is going to go down by one because you have one fewer student that you just selected. So you have 1241. So we would have 90 divided by 1242 times 114 divided by 1241. So there's a very unlikely chance, 0, 0, 6, and then 7. I'll round that to 4 decimal places since it's a smaller number. So that would be our probability. It's very unlikely that you would get a student from Vista and then a student from Oceanside. So just to point out some things, in this first example, our numerator decreased by 1 and the denominator decreased by 1 in the second fraction, whereas the second one, our numerator was a completely different number because it's a completely different town. This is the Oceanside number. Whereas this number, we had one fewer student, just like we did in the previous one. And this says fewer. So those are probabilities without replacement. So we've done quite a bit of probabilities with two-way tables. Another place you'll see probability with two-way tables is the SAT or the ACT. These are kind of common questions on those tests, particularly the conditional probabilities like we did in I and J. So I hope that this video is helpful. Give me a thumbs up if you like the video. Thanks for watching. Thanks for all your hard work during this distance learning. And we're almost there. We're almost to the end of the year. So congrats.